In the last lesson, we learned about the explosive growth taking place in mobile internet and in Internet of Things, and how all sorts of new industries are emerging, and how the new technologies are pushing ICT to evolve and pushing the release cycle to speed up. For example, high speed, low latency, and massive connectivity. When 4G was scaling up for commercial deployment, research into the fifth generation mobile internet, 5G, was already underway. So, what is 5G? Who gets to define 5G? Do you have any idea? In 2012, the International Telecommunication Union, ITU, started to work on a vision for global 5G standards and on the direction that future 5G research would take. In October 2015, in Geneva, Switzerland, at the 2015 World Radio Communication Assemblies, the ITU Radio Communication Sector, also known as the ITUR, officially authorized a resolution to move forward with research into 5G and gave 5G the official legal designation of INT 2020. After 2 years of research into the issue, the ITU vision for 5G is essentially complete. 5G will be used to connect the entire world, a fully connected world, a whole world at your fingertips. 5G is an end-to-end, fully mobile, fully connected ecosystem. From the small devices you wear, the connected homes, or cloudified offices, to the large-scale applications in industry, agriculture, medicine, education, transportation, or finance sectors, and more. 5G will connect it all. With 5G, you have a fully connected world at your fingertips. To fully realize the vision of 5G and to deliver services that are beyond the capabilities of today's 4G networks, the ITU has defined 3 categories of 5G applications. There is enhanced mobile broadband, or eMBB, to increase mobile broadband capacity. Massive machine-type communications, also known as mMTC, to resolve the massive connectivity issue. And there is ultra-reliable and low-latency communications, or uRLLC, for when we need extremely high reliability and extremely low latency. 5G is defined in terms of throughput, latency, and connectivity requirements. It will deliver 10 gigabytes per second of throughput, no more than 1 millisecond of latency, and 1 million connections per square kilometer. Let's now take a look at how the 3 stages of 5G applications will affect our lives. Starting with eMBB. 5G will bring us high-speed internet access, wherever we are, and it will enable new services such as VR and AR. You will be able to share anything you experience from any place at any time. You will never again have to experience the frustration of not being able to upload your videos directly from the concert. mMTC is designed to address the challenges of massive connectivity, to enable a society where all devices are smart devices. 5G's ability to support massive connectivity ensures that our wearable devices, smart home appliances, and smart city infrastructure all have easy, reliable internet access so that we can enjoy a smart, digital life. The shared bicycles, water meters, gas meters, streetlights, and so on will all be able to access the internet and provide personalized services to us all. The third category is uRLLC. The super low 1 millisecond latency afforded by 5G will make remote medical care possible, will bring us the convenience of self-driving cars, and make smart manufacturing a reality. Vertical industries like self-driving cars and smart manufacturing will be critical uRLLC application scenarios for 5G technology. In late 2017, the Huawei Wireless X Labs signed individual memorandums of understanding with multiple automobile and industrial robot manufacturers to promote 5G development in these vertical industries. 5G will be integrated into every aspect of society, creating a comprehensive, user-centered information ecosystem. The world today is slowly starting to agree that 5G will provide a better way to meet the needs of the diverse applications and service requirements of tomorrow. The world also agrees that 4G basic infrastructure needs to be vastly improved. User experience needs to be improved, and the already available resources need to be maximized. In this lesson, we learned that there is eMBB to increase mobile broadband capacity, mMTC to resolve the massive connectivity issue, and there is uRLLC to deliver extremely high reliability with extremely low latency. This brings us to the end of this lesson. In the next lesson, we will discuss the 5G protocols and standards.